Hello, everybody. Can you hear me? I sure hope so. Thank you. So, welcome everybody to this CIGRE TechOnline meeting that we're having, and I'm really excited to have more than 150 registered participants. Not everybody was able to join us yet. I think they'll drop in step by step. The next few minutes. So after the introduction, I'm guessing that we're already reaching the 100. So as you have noticed, we have a very interesting program to offer to you. I'm myself really curious on the presentations that we will see. You see the program displayed on your screen. We'll come to that later. I will not introduce the speakers myself, but everybody will likely be able to introduce itself for a very short statement, so we know who is talking. So it's really big success having so many people here, and on that behalf, I would like to thank already at the beginning Marcel Stöckli, the secretary of CIGRE and member of ElectroSwiss, for organizing. Oh, now we see your emails. Yeah, for organizing this meeting. So an applause virtually from everywhere in the world for you, Marcel. Thank you very much. So just before we start with the program, since we know, or I know that not everybody is acquainted and familiar with the CIGRE, I would like to give you a short introduction on who CIGRE is. This is, there's a global perspective, but also, of course, a short national perspective. So those listening or watching from abroad, you'll see what you can take with you with that. One more thing, you may have noticed that we are recording this session. So if anybody is objecting to that, please let us know. But I think it's a good thing. So if everybody misses a part, we can. It will be made available, and you can watch it offline if you have to. So what you see here is the global map of CIGRE. So CIGRE is covering actually the whole. Almost the whole world, with over 90 countries represented in that organization. So it's a truly global organization made for sharing knowledge on our systems. Go on further, Marcel. So what you can see here is the two pillars, or actually the three pillars on which CIGRE is based on. On the left-hand side, you see the geographic networks, which cover mainly the, let's say, the administrative tasks also of CIGRE, with the governing bodies shown here as the General Assembly and the Administrative Council, where every country is represented, and a steerco in the selection of the admin. Oh, once again, we see your email screen, Marcel. Go back to the presentation. Thank you. The steering committee, which is actually the main body steering the strategy and the development of CIGRE. And then, of course, we have all the national committees, 60 national committees, which drive the CIGRE spirit in their respective countries. On the right-hand side, you see the technological domain driven by the Technical Council, and attached to this Technical Council are all the study committees. There are 16 study committees. We'll see that in a minute, which treats the different technical topics. Central office is the administrative body. That's the only professional organization. The rest is all on voluntary basis. Central office, with about 13 persons, they drive the organization on a daily basis. And then, as you may know, there's the work group philosophy. Study committee defines topics. National committees look for staffing, and like this, there are almost 250 working groups assembled, which tackle a certain topic, and at the end of a working group, a document like a technical brochure is published to document the results. So that's, like, say, the daily business of CIGRE. And if we go on further, Marcel. Yes, then we'll see the extraordinary processes related around the Paris session and the different symposia. So this is then the traditional paper and contribution business, where again, study committees define what topics should be covered, and the National Committee, together with the study committees, they define or check the quality of the papers and the contributions given to these sessions. And then there's also more. There's tutorials. There's usually exhibitions. So this is the not recurring business that is also very important for CIGRE. One further. Here, just for your documentation, you see the governing bodies that you saw in the org chart before. So at the left side, the steering committee, and on the right side, the technical council. From a Swiss perspective, what is interesting is that Switzerland is represented in the steering committee as an important country, because we have a lot of members and a lot, of course, also a lot of industry that contributes to CIGRE. And on the right-hand side, in the technical council, also quite remarkable, we have 2 study committee chairs from Switzerland represented here, which is, given the size of the countries, certainly an extraordinary situation. But we're very grateful for that, because this gives also the opportunity to be very well connected to this organization. One more. This is the list of all the study committees, also for your documentation. You can find all this also, of course, on the website of CIGRE. There's the link on the page. You see the 4 groups: equipment, group B is technologies, systems, and new materials. So there's a topic, and IT. There's a topic for everybody, and all the important issues are covered by these the 16 study committees. Oh yes, here you see the grouping, what is bound together. So we have a section which treats mainly high voltage technology. And if you go one further, there's another one mainly on ICT, which is evidently getting more important year by year. And the third group is more on asset management and regulatory aspects. So as I mentioned before, for everybody, there's something. And as you may know, CIGRE also adopted an end-to-end approach to power systems. So this includes also the distribution systems. So not only the TSOs, but also the DSO problems and grid edge are treated within CIGRE. So I mentioned that before. You have working groups. That's a regular business, and the session-orientated work grouped around the Paris session and the symposia. On the left side, you see a list of the new working groups that were approved in 2023. So there's a lot of going on. I think every week there's 1 or 2 new work groups that are created and taken care of. You can find all these work groups on the CIGRE webpage. So if you look for an interesting topic, just look on the CIGRE webpage. Next slide, please. Oh, I'm already done. So this is about CIGRE. If you have any questions, don't hesitate to contact me or also Marcel, and we can help you. And at the end, we'll do a small commercial on how to get registered at CIGRE if you're not yet a personal member. So with that, then as an introduction, I'm right on time to introduce the first topic, net zero carbon, all around the GIS and the new gases and technologies related to that. And I'm more than happy to hand over to Robert. Please introduce yourself in a second and then start with your presentation.
Okay. Hello, everyone. I hope you can hear me. Yes? Can you hear me? Yes. Okay, good. So welcome to everyone. My name is Robert Lüscher. I'm working since several years in Switzerland. And meanwhile, I'm the R&D manager for gas insulated substation, working for GE Grid Solution. So you will hear something about the colloquium that has taken place in Birmingham, and I will like to give you some takeaways, what seems to be important in the view of GE Vernova as a company. So it's already on the first page. So one very important topic for sure is for future products and also existing product to have a look on the life cycle assessment, which is a key to evaluate the sustainability of any product, solutions, or complete substation to reach the goal of carbon net zero in the future. Let's start with all the presentation that has been done by GE on this event. So please remember, it's A3 and B3 joint colloquium. So that means we are covering substation and individual high voltage equipment. And how to reach the SF6-free products and solution. We had 7 papers presented different aspects of existing products for gas-insulated substation, for outdoor circuit breaker, AAS, and even dead tank circuit breaker, which was mainly used in the US market and in the Asian market. So obviously we have chosen one way to go for SF6-free products, and that's based on a flow nitrile mixture. So we call it C4F7N. And the mixture additionally contains carbon dioxide and oxygen. With those products that we have shown there, you can already be live in a substation. And we have many references already done for more than 40 utilities in Europe. So one of the key elements, as I have mentioned, we should compare the life cycle assessment of individual products or solution, even complete substation, to make a comparison between today's SF6 technology and future SF6-free technology. One key element is certainly that we have to move fast. So SF6 removal should be key. So once we have products, we should also use them in the field and build substation and get rid of the SF6, which we have used now for decades. Be aware that depending on the choice of technology, there might be an impact of the enclosures, so mainly the use of aluminium raw material, depending on the technology. Today, with the GE flow nitrile-based technology, we aim to have the same product size as with the previous SF6 generation. Therefore, it will give us a very low life cycle assessment when you do the evaluation criteria. It's too much to go into all those graphs which you are seeing on the screen. That's just an illustration that it is quite a lot of parameters that you have to respect, and not only the replacement of the SF6 gas as such. While we have done these 4 days colloquium in Birmingham, we have heard some voices from the utilities, mainly also UK utilities. So all new assets should be preferably SF6-free, wherever possible. We also need to have early technology adopters working with OEM to field test non-SF6 alternatives. So this is what has been done in the past. We are already beyond pilot stage. We are already in the serial stage. And to make this technology aware for everyone, there was a joint brochure which has been presented as a handbook for using application of C4FN mixtures from Hitachi Energy and from GE Vernova built together. A quick view what has been done in the past. So if we are giving an answer to SF6-free products, you see it on the map. The concentration is mainly in Europe. That's very obvious since the awareness of having this impact of SF6 is most likely in the mindset of the European people a little bit more established than the rest of the world. Nevertheless, in US, there are the first references, and also Korea is a market that is following this trend. You see the number of installations of different kind of products, and there is not one single user that has chosen the technology SF6-free. There are more than 40 leading utilities. A regulation and F-gas. So it's a long story. GE is definitely committed to deliver products according to the latest regulations. The regulation is ongoing. I mean, there is a so-called trilogue between the European Commission, the Parliament and the Council. We expect that this is going to have a conclusion till end of this year. So now there is Spain who has taken over the presidency of this trilogue till end of the year, and we expect a result till end of 2023. There is a major move towards a global approach of energy efficient over the product lifetime and LCA to evaluate the product benefits when going from SS6 free to from SS6 to SS6 free solution. And as you can see, European Union is well aware that some companies are really keen to develop quick solutions to be applied in the market. There are 4 main projects which are sponsored by the European Union to advance gas-insulated substation up to 420 kV, and also GIS 245K and even live tank. So there is quite a commitment to go quick along the road and to get rid of SS6 in a reasonable, fast way. From GE point of view, we have presented a 420 kV circuit breaker with all the type tests. There was a 245 kV AIS single break paper and a 145 kV 63 kiloamp dead tank circuit breaker paper, including the most severe transformer limited fault, which are defined in IEEE, and also shunt reactor switching, which is an extended capability of a circuit breaker showing its behavior to synchronize shunt reactors on and off to compensate load in the network. And as I've mentioned, some LCA studies with best practice and how to evaluate the carbon footprint of a solution. Just quickly, I will jump into the one of the articles. So this is paper number 127. You see that the key performance have been demonstrated. You see all the different graphs in the paper when we have done the type testing in the external lab. And most important, we also have given a life cycle analysis of the new equipment, which has basically the same footprint as today's solution. Same story, this is just an example, paper 136. Here, the demonstration of a single break platform. So it means one single interrupter for 245 kV for an AIS breaker. And this is more or less a derivative of our GIS 420 kilovolt breaker, which is this one, which has 2 interrupting chambers in series. If you take only half of it, you get the IAS circuit breaker, which has been shown in the other paper previously. Most interesting, these kind of products are so compact, even when going away from SS6 technology, that they can be fully assembled at factory and delivered to site. So that saves a lot of troubles for the installation. And we call it dual gas. So the system is designed to be used in SS6. And also it can be used with our new technology based on nitrile, which gives the opportunity to even start with SS6 and then later on convert to a flow nitrile based solution, or starting from scratch directly, completely SS6 free. As a summary, I have just concluded all the points I already mentioned. So 7 papers have been shown. We make a lot of focus on the life cycle analysis for the products because we think this is the most fair evaluation criteria to compare technologies. It's, by the way, also indicated by the European Union as a standard procedure when procuring materials in high voltage switchgear. And we have presented various results of today's SS6 free products which are used in the field. Very severe switching operations, and we think that the chosen way of flow nitrile based mixtures has no limitation in terms of technical performance, and we are quite keen to fulfill the complete product roadmap and portfolio within the next years. So I think I'm quite in time, 10 minutes. So I finished. This is my last slide.
Thank you very much.
You can take over.
Yes. Next,
Yes.
please.
Okay. Perfect.
Then I will seamlessly connect. So hello everyone, and welcome to the next part. This will be the Hitachi Energy update from Birmingham. My name is Michael Gatsche. I work with the Technology Center of Hitachi Energy in Zurich-Oerlikon. I'm a principal engineer there, and my work is focused on the SF6 alternatives basic technology development. And for Birmingham, I would say from our side, there were two focus points that I would also like to highlight today. The first one is the SF6 free switchgear for 420 kV. Here we had a detailed update on the type test. I will show some excerpts from this, and also I will address a bit the technology essentials, what is necessary to have 420 kV SF6 free switchgear. And then I will also give a general technology update. And here there were two topics that were often discussed. That was the C4FN supply and also the handbook that were already Robert gave some indication. Okay, let's start. So what is the story about the SF6 free switchgear for 420 kV? And here the main story is that the world's first modern SF6 free 420 kV circuit breaker has been fully type tested. You can see it here on the right side in the STL accredited laboratory during the L90 test. And it is a gas circuit breaker using the puffer principle. It is a double break, so it has two chambers that are connected in series. Each chamber has a grating capacitor, and it is operated by one drive, which is a spring with the spring hydraulic mechanism. And you can see this here on the left side because it's a lab test. It's without the drive cover in this picture. The gas circuit breaker uses a gas mixture of carbon dioxide, oxygen, and fluoronitrile. And as you will see later on, it is really a platform approach. So the same interrupter has two main applications for GIS and for dead tank breaker. And it's also covering 50 and 60 Hertz, so IEEE and IEC, and was also tested accordingly. And yeah, I will go a bit more into detail on the next slide. So one focus point, or what is very important, is the capacitive and the shunt reactor switching. So for capacitive, we did the line and cable charging according to the class C2. And it was done for 60 Hertz and with the capacitive voltage factor of 1.4. So we think that's a really good rating covering a lot of applications. And then also the shunt reactor switching, where we did an extended program with all shots cleared. And what we saw even there, when we compare with our SF6 reference, we have a very large reignition-free window that is even larger than for the SF6 breaker. And we have a very low likelihood of multiple high-frequency reignitions. So we would say that's generally, of course, an advantage of gas circuit breakers compared to vacuum, this very low likelihood. And what we have seen is that with the SF6 free technology, the likelihood is even lower than with SF6. So I think really good performance, really good ratings that we could achieve here with the circuit breaker. To summarize the type test, you see here the big table of all the type tests, and you see that there are some fields which have the same color and which are adjacent to each other. And this means that this type test, because it's such a big series with 50 Hertz, 60 Hertz, IEEE, IEC were done on the same test object. So for example, here T10, T30, T60 were done on the same test object. And we have some general learnings from this test. So for example, that short line fault 75 has a larger margin than the L90. The breaker also withstands the higher IEEE ratings or TRVs for T10, T30. We have 75 milliseconds DC time constant for the T100A. And as we've seen in the previous slide, so it has really excellent and reliable behavior during the shunt reactor switching. So we believe it's a really good circuit breaker and can address also the global market really. And I can really recommend to read the full paper. The link is here that my colleague Valeria Tepati and team have written. And yeah, it's really a recommendation for a deep dive and to find more details on this new technology. what I can give as an update today is that not just the breaker is fully type tested, but also really the pilot project for the dead tank breaker application. There was last week done in our factory in the US, the successful factory acceptance test and the handover to the user. You can see the circuit breaker with the 3 poles here in this picture. And what you can also see, of course, they are the proud team. And I also have to say from my side that I'm very proud to have today the opportunity to present this effort of the whole company, of all the people involved to achieve this. And what we see is that basically with this milestone, we now have the SF6-free equipment available up to this transmission range. And really in this transmission range, this is where the large gas volumes are, where we will have a big increase in the next years of strengthening the infrastructure. And now we have the option to actually do this SF6-free and to reduce the CO2 equivalence of the gas in this circuit breakers in the GIS by 99%. And with this, I want to go, let's say, more to the technology. So how was this possible? What are the essentials to make this SF6-free possible? And for us, this is really two factors. First is the gas circuit breaker technology, and the second one is to have the gas mixture with the fluoronitrile. So the gas circuit breaker technology is time-tested and proven and reliable. So we have decades of experience with SF6. The scalability is proven, and we are developing up to 550 kV now, but we can also go beyond. There's no limit in the scalability. And when we look for the SF6-free technologies for the breakers, the gas circuit breaker technology is the only technology that is proven for 420 kV. So for example, for vacuum, we don't have this option but for 420 now. And the other one is the gas mixture with the fluoronitrile. So there's the question, why do we need the fluoronitrile? So also there, when we go away from the SF6 to the SF6 alternatives, the C4 additive is the only option to have a high dielectric performance that is comparable to SF6. And this high dielectric performance enables compact equipment. If we leave out the C4, the dielectrics go down and then the size increases. And I mean, there we have seen a lot of studies, but typically in one dimension, it's 50% bigger without such a dielectric booster. And of course, when you think about a complete substation, it's not just one dimensional, then you have also height and depth. And though there, the size increase can even be higher than 50%. But also what Robert mentioned earlier, this has also an impact not just on the compactness, but also on the material consumption. So more compact equipment means we lose less aluminum, we use less steel. And this has also really a positive impact on the carbon footprint over the whole life cycle. So the LCA, we firmly believe that this is really the best technology to have the lowest LCA, and this is proven with a lot of studies. And because we come in this range of SF6, we have, for example, for this 420 kV GIL model, also the option to retrofill the bus duct and have basically swap out the SF6 without changing the equipment, and also there address the needs of the installed base. Okay. Let's say from this, another technology update, the gas supply is a big topic. We know a big US-based manufacturer will stop the production of the fluorinated compounds in 25, and also the C4 is affected from this. But in the row of or in this general thing, also this manufacturer has given up the IP on the C4FN. And this means that there's now no limitation for the use of the C4 in the high voltage equipment. And this means that also there are now more gas manufacturers have the opportunity to supply the C4. And already now alternative suppliers exist and have a production capacity. And what we have tested in-house is gas chromatography of these alternative suppliers, and we see that this is all within the specification that is discussed in IEC that will be included in the upcoming 63360. So also there the properties are identical. And The second part on the technology update is the handbook. I will keep it short on this slide. There I can thank Robert Parsley for already introducing this concept. So you see some authors from GE, some authors from Hitachi Energy have worked on this. And what we were aiming at is really giving a practical or user guide on the technology. And one example is, of course, gas qualities and gas handling. So this is, for example, an excerpt of this. In the center, we have the high voltage equipment, for example, the GIS, and we want to fill it, for example, in the commissioning, but also after repair, and of course also for a top-up, we could have the filling. And we see there we have different options. There are different equipment available to do this. We can relate this to the gas qualities that will also be defined in IEC. And then also we take out the gas, for example, for an overhaul or at the end of the life. And then also there the gas qualities come into play. We can analyze the mixture and decide if we can reuse this to fill other equipment, or we can even let's say recycle and pull out the C4 and use this then again for filling operations. So I would also like to invite you to have a look into this handbook. This is publicly available on the websites. For example, here's a link, and there you can really look at it, look at the technical characteristics of the mixture, health and safety aspects, and the user guide on the gas handling. And of course, also we welcome any feedback on this. So yeah, with this, I would like to end my presentation, and already thank you for the attention.
Thank you very much, Michael. So I'll hand over directly to Bruno. Hi, Bruno, go ahead. We can't hear. I can't hear you. Can you hear Bruno?
Me neither.
No.
We cannot hear you.
Nope.
I quickly suggest we go to Christian Lindner then, if that's fine.
If you can hear me, yes.
We can hear you.
Good.
Yeah, so
Okay.
Christian, jump in, and I hope that Bruno can solve his problems, and then we'll switch back. But go ahead, Christian.
It's nice to be the backup. Welcome, everybody. The slides, Marcel, are you putting the slides on then, or is...
You can put yourself directly share.
Okay.
You can hear me?
Yes, Bruno, now we hear you, but we continue with Christian, and then we switch to you afterwards, right?
Which slides do you see?
Hello, everyone. Can you hear me now? It's
Bruno, we can hear
okay,
you, but we will take you afterwards.
Sorry for this troubles. Now I'm back. So here we are.
Okay, then we go with Bruno. Is that fine for you, Christian?
Yes.
Good.
So here we are. Okay, my name is Bruno Herzog. I'm the head of grid technology in Switzerland. I'm responsible for all the grid technology items for the transmission department. I would like to show you some updates from our company, from Siemens Energy. This presentation was done by Mark Kuschel, my colleague from Germany in Birmingham. So my former colleagues presented the SF6-free solution based on mixture gas, and I think it's very important, as you understand, our technology is really different. So Siemens Energy is following the clean air solution. That means we are really focusing on F-gas-free technology. So what is it behind? So the clean air is a mixture of nitrogen and oxygen. As you can see, it's many years ago already presented in CIGRE in Paris. So it's not only Siemens Energy which is following this technology. There are other suppliers worldwide which are using this technology. So what are the key points there? So the global warming potential is equals 0. That means really the best solution in this case for the GWP. Then another issue is the toxicity, the stability, and as well, not mainly in Europe is important, but I think in other parts of the world, that the minus temperature we can handle without any additional mixture of other gas. And then, as we learned in the first project in Switzerland, so there is really easy to get the gas from many suppliers. You can buy it as a standard solution. So that means that's a technology on the insulation side. And then in the combination with the vacuum interrupter, as you know from many projects or many products in the medium voltage, so since more than 40 years, vacuum technology is used for GIS solution, but as well for the IS. So that means we are combining this both together, vacuum technology together with the clean air. As well here for the interruption, because it's closed, so we have no toxicity. It's going out. Then we have really a high performance of the vacuum interruption. So we know it many years from the standard medium voltage, but as well for the high current generator switchgear, for example. So that means there we have really a long experience in this capability. And then, yes, sealed for life, vacuum works only if it's really closed. When not, then we have really a problem. Okay, so that means that's the main difference between the other two suppliers. We heard the solution before. So what are the experience in this area? So we talked a lot about the GIS switchgear, RIS as well, but we are following as a company as well to use the clean air technology for the instrument transformer, for example. The tank is already mentioned, and the GIL, GIB as well. So all in all, since 2017, that our first installation was done, with 50 kilovolt IS circuit breaker, then we developed step by step, and now we have more than 1,500 units installed over the world. So that means as well here, we are not in the pilot phase. We are now, most of the products, we are on a standard base, so it's up to 145 for the GIS is running as a standard product. And for high voltage, today we are able to have the GIL ready, but you will see later on as well for the other development. The main focus was in the beginning of the wind application. So most of our customers, they are using wind turbines. They prefer to have as well a clean GIS insert of the wind tower. So that's really the huge installation is coming from this part, and we are using this experience as well for the other development of the products. So just to show you that this is not only in the factory tested. Now we are ready really in Switzerland. This is our first installation of the Blue GIS 145, and we have successfully tested with FKH the high voltage test, and equipment will be ready this summer to be electricized for the whole system. How it looks like for the future. So as the colleague from Hitachi and she mentioned, really the demand is on the high, very high voltage. 420 kilovolt is really a huge demand, and as well an effort to reduce the SF6 there. So due to that, we are now able to have the GIB there ready, already available. And the next one will be the development of the development is already done. The tests are done for the circuit breaker, and the additional parts will follow up. And then we go as well with the dead tank breaker, and later on, mainly for Switzerland, it's interesting to have this for 245. As you know, Swissgrid is using most of the substation this level, so we are able, beginning of 28, to follow up there as well. So this is our roadmap, how we see the future for the clean air technology, full F-gas free, and yeah, we are looking really forward that we can supply or support the demand on the market for this application. Thank you very much from my side.
Thank you very much, Bruno. So I'll hand over now finally to Christian. I hope you got your presentation ready, and it will be certainly interesting to see the perspective of operator also in this this topic.
Can you see it now? Slide.
Yes. Now you could put it full screen, but we can already see it. Yes.
So try to make full screen. Yeah, no, thank you very much, Rudolf, Rudy, that I can show this short slides to the community. My name is Chris Lindner. I'm the head of engineering at Augsburg in Switzerland since a couple of years, and my background is at ABB and Alstom, developing high voltage breakers. That's really, I'm very glad to see that how the manufacturers are really now developing and bringing on the market SF6-free products. I will show a way, or let's say our perspective as a grid operator to become CO2 free, which is actually maybe upfront to say not witchcraft, and I will show today about what our plans are. Currently, Augsburg is working on a new sustainability strategy. The executive board is working on it, and I think by winter this time, this information will come to us, to the grid division, and then we are going to derive out of this a sustainability strategy for the Augsburg grid. So we have here about we are meeting the transformation from the 50 to 110 kV, or let's say in the last 5 years to change the 50 to 110 kV. And what I would like to show is what we are monitoring. Oh, I think everybody which is a grid operator are monitoring that, his own losses, the true losses, and which we have about 140 gigawatt hours. And if you transform that or calculate that to CO2 emissions, then it's about 12,000 tons annually on the indirect emissions CO2 on our grid. And when we are using the Swiss user mix of 128 grams of CO2 per kilowatt hour, and we have a couple of kilograms of SF6 losses in our grid, and with a leakage rate of about 0.2%. So this is also this CO2 equivalent. I think it's all in all, it's about 20 kilos or something. Totally, Switzerland has about an SF6 emission of about 530 kilograms of SF6, and we are voluntarily monitoring the SF6 emissions. But coming to the life cycle assessment, which is something which we want to do more and more. In general, it's nothing like making a bill of materials and looking into the CO2 footprint of the different components with the manufacturers. And we, from the energy side, we talk about the load curve of the how much load through a transformer and through a substation is running. So this is kind of feedback from our side. And at the end, we are coming up with a CO2 equivalent. And particularly in these presentations today, I'm just focusing on the CO2 equivalent. Jumping into a 220 kV GS substation here in Switzerland, just to give you an idea about the CO2 equivalent, which is over about 30 years time, about 7,000 tons of CO2, just to get a feeling on the size of it. Considering the loss rate of SF6, which is much lower than IC, this is just for the calculations. It's not the real figure. It's just for the calculation. IC is recommending 0.5%. Here we consider 0.1%, and what we're considering as well, that 80% of the load for the high voltage products is about 25% of the nominal rate. But no surprise. Here is that, of course, almost 50% of the CO2 equivalent for your substation is coming from the transformers on the bill of the material, etc., plus losses. And the GIS, because I'm jumping into that a little bit later, the GIS is about 20%. But this here, it's an SF6 solution. It's not and SF6 free solution. It's an SF6 solution. It's about 7,000 tons. When we are looking then into the electricity consumption over the 30 years of this substation, it's a 220 kV substation, and certainly the electricity is running through the systems and through the transformers, through the GS, through the disconnectors, or whatever, and it's also not a surprise that for this 30 years lifetime, the transformer is certainly the major responsible for the electricity consumption during 30 years in your grid. So it's in this sense, it's about 1,800 tons of CO2 in totally in this 220 kV GIS substation. Jumping into the way now towards CO2 neutral. At the very beginning, when we were installing the GIS 220 kV transformers, and this is an SF6 GIS, you see on the CO2 equivalent, because this is the CO2 footprint just in this cake. The major part of the CO2 footprint on the substation is due to the SF6 losses. So it's more than 50% of your CO2 footprint of a high voltage substation is coming to SF6 losses, considering here a leakage rate of 0.1% per year. And then the other part, true losses, and then the manufacturing losses. But let's assume now we have a 220 kV SF6 free solution. Then what stays as CO2 footprint is the true losses and the losses of the manufacturer. Yeah. And what we are currently doing is we are asking the manufacturers to, on their sustainability programs, to become CO2 neutral. And we have got answers that up to 2040, 2050, the manufacturers will compensate their CO2 footprint so that it will be CO2 neutral in a sense. And what we are using is we are using EcoVadis as a quality certificate. EcoVadis is what we are asking the manufacturers to get certified of, and there are also some manufacturers already here in this meeting which have the gold certificate already. But this will be a key ask from the purchasing guys on the EcoVadis certificate. And if the manufacturer is becoming CO2 neutral, then what stays, it certainly is the true losses. And these true losses we can certainly also compensate at the end when we are buying our losses with renewable resources. So the residual is just to see how our operation and maintenance guys are using their equipment and their work to become CO2 free. So in that sense, it's a way towards CO2 freedom on a high voltage substation or even high voltage grid. It's not witchcraft, it's just a question of time, and whether 2050 is still okay, or maybe we can make it earlier. An LCA study here on a 145 kV substation. This was a 2016 project on the first G-Cube GS substation in Etzel. This is now since 6 years in operation, which is pretty fine so far on the GIS. And when we started this project, we were looking at the CO2 footprint as well. And at that time, compared to an SF6 solution, the SF6-free has a major reduction on the CO2 footprint in that case, in this substation. There are no transformers considered in this LCA analysis, but nevertheless, as we have seen before, the SF6 is more than 50% responsible for the CO2 footprint of your substation, and this you can get really rid of. And this was nice to see, and then the rest could be the compensation of the Joule losses. The next step will be a substation Beringen in the Schaffhausen area, where we are starting a life cycle assessment with GE, and there we were considering transformers, medium voltage, and GS. This is an SF6-free substation, which is currently under construction. And the eco declaration will be completed by autumn this year, and I'm planning to present the results that at the TMD days at Pfiffner Group in autumn this year. So this is ongoing. And the last slide, as I said, what we are trying to do here at AXPO is considering the environmental parameters in the selection of the technology. We ask at the procurement for the EcoVadis certificate, and then at the end, so we are trying to compensate then the residual direct and indirect emission. But what we are going to do, we don't know yet. Atmosphere is a possible certificate. Some utilities in Europe are already compensating their SF6 losses with certificates at atmosphere. What we are going to do at AXPO, I don't know yet. As I said at the beginning, we are starting with our sustainability strategy by autumn this year. Yeah, that's what I wanted to say. Thank you very much for your interest, and it's up to you. I give the voice back to Marcel and Rudy.
Thank you, Christian, for this interesting presentation. So we're a little bit over time, but I still would like to give maybe, we have 2 questions in the chat, which would be, I think, interesting to just quickly respond to. There's one question concerning the detection of SF6 leakage. Or can somebody answer that very quickly or give an answer in the chat? And the other one is a question concerning pressurized air cables. I'm not sure what the person refers to. Oh, Walter Holhaus. Okay, so that's referring to Hyperduct, I guess. I think this was maybe for you, Christian. You can answer him directly in the chat. It's okay.
The high voltage, the pressurized cable is a very interesting topic in terms of life cycle assessment, and in particular when it comes to reduce the transmission losses, and the bill of material is pretty straight. I mean, this has certainly a very interesting potential on the application when it comes to life cycle assessments and life cycle costs. Pilot projects trying to find what the applications will be. We'll see it. I think it has its time. And the other question was on the SF6 sniffer. Yeah.
Yes.
Yeah, this is certainly we are not walking every month to the substation to sniff all around the SF6. I mean, basically the SF6 leakage rate is very low, 0.2%, and people are just watching the manometers. But if they are seeing that the manometers on the air pressure or the SF6 pressure has a kind of extraordinary higher speed than usual, then they're gonna sniffle. And for the calculation which I've shown before, we were considering no maintenance during 30 years. So there are no SF6 losses to be considered due to the maintenance work. But this is just a study. Certainly, you do something at 20 years, and then you have to take care of the maintenance people, what they are doing with the SF6. And most probably these losses are higher than the losses during the operation. But everybody has to handle that itself in his grid.
Okay, thank you very much, Christian. So we move on. Next part is study committee updates. And I would like to hand over directly to Mikhail. Go ahead.
Yes, hello everyone. I hope you can hear me. And I had some network connection issues here, but I hope that my voice will not break up. Yes, I'm happy to be here. Welcome also from my side. My name is Michalis Vassiladiotis, and I have been with Hitachi Energy Switzerland for the last around 8 years. I'm currently leading the R&D team of power conversion in Turkey. And here I am also presenting you in my capacity as a representative of the study committee of B4 DC systems and power electronics. So we will jump now to this world where also other type of breakers are needed with high voltage DC and so on. First, I will show you a little bit of B4 facts and some selected status updates from some ongoing working groups. Then there have been 2 recently approved working groups in the B4 study committee in Switzerland. So we'll spend some time explaining what it is, and then we're also looking for some nominations there. And some other topics are the contributions also for the papers in the session 2024 in Paris, and also recently published technical brochures. So if you're not familiar with B4 called DC systems and power electronics, so mostly what is covered here is the high voltage direct current systems and also the associated equipment related to that, mostly in the sense of power electronics, but also other equipments. So the first axis is of course HVDC itself, where the biggest focus is. But also other DC voltage levels for mostly distributions like medium voltage, and also even low voltage DC are being investigated. Then there is a second axe which refers to AC systems. So in the sense of flexible AC transmission systems or FACTS. And the third axe is about power electronics. So that is also the devices themselves and recent advances in that field. What is not covered is overhead lines or cables, which might be used by DC systems. If I'm not mistaken, there are some other study committees related to these topics. But also, for example, energy storage and lower voltage, also in the sense of e-mobility, decentralized energy sources are also partly covered by this study committee. And members come from anywhere between manufacturers and transmission system operators, distribution system operators, but also research institutes. And this committee is also pretty active in trying to recruit young engineers to participate in these activities. So some facts, chairman is Joan Hu and secretary Rebecca Ostash. And we're currently composed of 4 advisory groups and 15 working groups. And additionally, there are also participation in 6 further joint working groups with in collaboration with other study committees. And yeah, as you see, yes, the biggest focus is on HVDC. There is some also interest in FACTS and MVDC, which is more also the interest, I would say, in Switzerland. As you see down here, this is also from CIGRE published material. You see that from 1970 up to Up to today, there has been a quite a rapid growth of number of projects and installed DC power capacity, both in line commutated converter technology, but also in the recent, I don't know, 10 to 20 years, there is a strong focus also on voltage source converter technologies. And you see that up to 2050, there might be a forecasted number of 350 projects in total, covering both technologies. And there was also quite some peak year of installed capacity, like 2017. But by last year, the total installed capacity is around 315 gigawatt, and reaching also maybe doubling its size until 2050. Quick words about two ongoing working groups where also we participate from Switzerland in the group as members. So the first one was formed end of last year and regards grid forming converters for securing reliable operation of future electricity systems. So this is a quite interesting topic. Now the team members have been onboarded, and the outline of the technical brochure has been agreed upon. You see that the topic deals from defining, first of all, what we are talking about when we are discussing about grid forming converters. I mean, we know that with the decentralization of energy generation, we move into lower inertia grids, and then we need to use some kind of virtual inertia, or using converters and their control to emulate behavior such as synchronous machines. But there are still a few topics that might not be clearly defined in this term, and then the study committee will try to somehow consolidate all these views and come up with a proper definition. Then, of course, we have some subgroups related to what kind of services such converters can provide to the grid, but also the tools associated to this type of analysis. And then, of course, in the future for manufacturers, it will be relevant to, of course, how we comply with such, let's say, grid codes and such requirements. So there will be the attempt of developing some kind of benchmark test systems and models in order to perform such compliance testing studies for grid forming control. And then at the end, also some good practices are going to be documented from different projects and deployments around the world. And the second group is about power electronics based transformer technology. You might find this also in the literature and in global terminology as a solid state transformer, SST. So these are the power electronics based devices who are supposed to a certain degree to replace the traditional heavier and bulkier transformers in several applications by moving the transformation frequency into a higher frequency so that it can be more compact in size, and at the same time add some controllability and ancillary services features, since these are like power electronics based devices which can be accurately controlled. So there are different chapters in this working group, from functional specification descriptions and also a thorough investigation in terms of different architectures and topologies. Also the basic control, which should govern this kind of systems, but also how in the future things such as type tests or factory tests could be potentially defined for customers that are going to use this kind of systems. What type of grid services could be offered, but also, of course, and quite importantly, what could be feasible business cases and the economical assessment that goes around it, in conjunction, of course, with the existing projects and installations. So there I have been informed that there have been some delays due to also change in personnel and some scope. So the first draft chapter provision should have taken place in year 22, but this has been shifted to this year. Then there are two new working groups that I would like to mention here. The first one regards the developments in power semiconductor technologies and applications in HVDC and FACTS. So yes, it is clear that such power semiconductors are key components in this type of converters, and they define the performance and protection needs. Nowadays, of course, silicon devices are the state of the art of such converters, such as thyristors, IGBTs, or IGCTs. And the last actually technical brochure in the topic was published in 1997. And since then, of course, there have been a lot of technological advances, mostly in the area of using new materials, such as wide bandgap semiconductors, for example, silicon carbide. And there is a lot of investigations right now around such feasibility assessments. So this group scope actually regards to make a new assessment of what exists right now in terms of power semiconductor materials, their characteristics, losses, mechanical also integration, housing, for example, and mounting technologies. At the same time, how these power semiconductor devices can be controlled and what the interaction of these devices are with other elements of a converter, such as capacitors and also other parasitic elements. Something very important, of course, is impact of characteristics to losses, which is something that is very interesting for these applications, minimization of losses, but also from a manufacturer perspective, short circuit behaviors and fault handling are of major importance in regards also with reliability and different design factors, which could have also eventually impact on ratings and so on. That is the first group. And the second group, which has been approved, regards actually HVDC connection of power systems with a high integration of photovoltaic generation. So what we experience now is a rapid ongoing growth in installed capacity in this type of also renewable energy generation. And voltage source converters are one of the promising technologies for transmitting over long lines. There have been also a couple of projects, either demonstrator or commercial ones. And of course, associated technical challenges. For example, we mentioned also before low inertia, risk of oscillations in many different frequency ranges and grid stability. So this group is supposed to investigate these topics and come up with simulation methodologies and also solutions such as control systems or stability analysis tools. And going only quickly through the call for papers for the Paris session 2024,
yes,
as you see there. Yes, I conclude. Yes, preferential subject 1, 2, 3. We had 3 synopses submitted to the National Committee. Maybe in the second deadline there have been more. And just closing with this slide about technical brochures published in 2022, there have been 3 different ones on medium voltage DC, HVDC circuit breakers, and also flexible transmission systems controllers for commissioning, compliance testing, and model validation tests. So yeah, I hope I did not exceed the time too much. Thank you very much for your attention, and back to you, Marcel.
Thank you very much, Mikhail, for this interesting presentation. We move on directly to Mark Yaisi from Bouygues. Go ahead.
Yes, I hope you can hear me clear and loud. Hello, everyone. So my name is Mark Yaisi, and I work for a service provider called Bouygues Enertrans, same company like Rudy, and I'm the SCB5 representative for Switzerland. I will present some news about the study committee B5, protection and automation. I have put together the following 4 topics. I will do a digression how we organized, then the active working groups in Switzerland, some publications in 2023, and a quick outlook. The study committee organization looks like this. We have a chairwoman, is Ranveig Loken from Norway. She's also in the strategic advisor group and the tutorial advisor group by Klaus-Peter Brandt. And of course, I forgot the secretary study committee. He has a secretary, Richard Adams from the UK. Then we have some thematical groups. There are substation automation and remote control and protection monitoring and new networking requirements. And also with this 3 thematical groups. In these 3 thematical groups, we have some working groups. No working group are nothing with regular members, distributions, and observer members. Regular members, we have 24 all over the world, and regular members 4 and observer members 18. Move on. Active working groups. We have 27 ongoing working groups for the moment. Switzerland is represented in various roles in the following 7 working groups. The one with the red frame, I marked it, is Klaus-Peter Brandt. He's a convener from the working group B5.56, the optimization of protection, automation, and control systems. Then the B5.63 with Selko Schneider. He worked in this group at the team Protection Automation Control System Asset Management. Then the B565, Colin Scoble, enhancing protection system performance by optimizing the response of inverter-based sources. Klaus Martin Schäfer work in the group B5.72, modeling, assessment, and mitigation of protection. Sebastian Schneider from Switzerland works in the group 5.73, experience and trends. Alexis Rumpis is a convener in the working group B5.76 with the team architecture, standards, and specification for metering. And me and myself, I help out in the working group 5.77 with some nice and interesting IT/OT themes. Yes, for further information or for details can be read in this presentation, and the content of the working groups can be found at the SCB5 web page. We are always happy to welcome people who want to work in working groups. Please contact me when you are interested to be a part from the STB5. Move on to the publication in 2023. We have these following two publications. The first one is the Protection Automation Control Architectures with Functionality Independent of Hardware. This brochure proposed 2 promising technical concepts for IDs and centralized protection and control systems. I saw a lot of them at the CIGRE in Rome last week. Related requirements, limitation reference architectures as well as expected. Second one is the protection for developing network with limited fault current capacity of generation. This brochure researched the performance of traditional protection in order to terminate the protection components principles and explore new protection principles. Yes, and for all of this, you will find the brochure at the CIGRE.org webpage. And a little hint, for CIGRE member, they are free of charge. This is my last slide, a little outlook. We are looking forward to the next year's CIGRE session number 51 with the following 2 preferential subjects in our study committee. The first one is the practical experience and new developments of process bus, means experience feedbacks and implementation of IEC 61850 based process bus, synergies with virtualization, use of process near interface intelligence electronic devices called ID, and low power instrument transformers. The second topic is acceptance, commissioning, and field testing for protection, automation, and control system, current practice and experience feedback, challenges, perspective for a new era of protection, a big word, automation control system, and also the skills, tools, and testing methods. Yes, you are all invited for the call of papers. And for further information, you will find it at the CIGRE web page. I'm write it here down. Yes, I'm finished. I make the time good. Thank you for your attention. Enjoy the rest of the meeting. Thank you.
Thank you very much, Mark. 27 working groups, that's really a lot. So that proves that this is a very active study committee, and that's a field that is very progressing at the moment.
Yeah.
Okay, so I'm happy to welcome Nora, who will present an interesting project, which is finished, almost finished. Actually, it's finished. Some small tweaks still going on, but Nora, please go ahead and show us this interesting project.
So let's make a sound check. Can you hear me? And you're seeing the slides. So yeah, so technique has worked. Well, my name is Nora Barrera. I've been working for Swissgrid for the last 4 years now as a grid project manager for substations. And I was extremely surprised and thankful for the opportunity to talk a little bit about this project. I've been so focused on the work. It has given me an opportunity to reflect on it. So those are I hope you find it as well as interesting. And I want to show you just a couple of just bring you to the project, show you what, by the way, this is the finish project. It is so quick, it's just done before we started. But so let me get here, the next slide. Just bring you a little bit to where it is, what the starting points, a little bit of the timeline, how about some points about the planning, construction. I'll take you in a graphic, project execution, and then share with you a couple of points that we kind of like sum together the work that we did. So every beginning needs a starting point, and that's what I thought maybe with this was a photograph from the 23rd of September. This is kind of like the premises in GE where this power plant is built just before it got transformed. So to the, is working. Yeah. So needless to say, in last summer 2022, there was a lot of talk about this power shortage and what is Switzerland going to be doing about it. So many emergency discussions took place, ending up with a order from the government to GE to build this temporary reserve power plant. So we see those 4 letters in many publications. And the place to be is here you see the premises from GE. Basically, this parking lot here is converted to the power plant. This green spot that I'm showing here, that is where a GIS got built to receive all the energy generate to receive the generation. Then down here in the middle, there is testing facilities from Ansaldo that got used. So let's see what happened. As soon as this order gets in place, there just starts a lot of questions. And I think a very important one is, okay, well, we're going to have a power plant, but who is going to operate it? Who are the partners? So because this is something that it was just not usual to talk with. So parallel with all this is how do we start the whole thing? And the more questions just keep on popping up. Where are we going to connect the power plants? Fine, but where are we going to go connect it to the grid? What is the transmission capacity that we have to talk about? How do we do this connection? The closest substation is going to be Beer, the 220 kV. We knew that was going to be a level, but is it going to be with cable? Are we going to use overhead line? And then part of in the project, there's an existing cable. I'll show you in another slide, between the premises, not quite where the power plant is going to be placed, but to the to the substation. So could we use this one? Finally, on beginning of September 4th, Swissgrid then receives this official grid connection request from GE. That is basically, generally, that is the starting point. Of course, conversations were much before that. And there is a date. So listen, we have to be ready by winter. So this is February 2023. And I want you just to note the difference between receiving the start point and the end point, just to mention. So then we start saying, like, how is it going to be possible? How are we going to make a line between those two dates? Where is the equipment? What are we going to put? Where do we find them? Where are we going to, where do we going to get our civil contractors? We have to order the cable, and the list just was endless. So, yeah, no, this February 2023, that's important one. So let me take you along with all this a little bit in the geographical situation. We see then in the photograph here the GE facilities, which are in Bier, and just over a kilometer away is the substation of Bier. Here to the left, you can see that's the Gemeinde in Bier. Now, this is within these facilities, we have here, there is an existing cable connected from these testing facilities from Ansaldo down to the substation. And then it was a question, can we use this one? Is that a viable solution? Basically, I can tell you after a few discussions is that, and as well, remembering the timeline that we had, that by placing the GIS here and placing a new cable towards the facilities, then we can connect them in series and then be able to actually get ready the connection. Once we left this premises, we would have to go through a lot of different requirements from the construction for a construction permit. So let me show you then basically the final design, and that is what we have now on site. The red boxes are showing where the power plant is being placed. We have here the 8 units, the connection to the step-up transformers. So from 8 units, it's connected in pairs to 4 step-up transformers, and these are connected in parallel 2 lines then to the GIS. And then from the GIS, we have this new cable connection towards these facilities. That was kind of like the solution that after few variants was accepted. The single line diagram looks therefore like this. There's at the moment a total installed capacity of 250 megawatt. Use with 8 GE units. Showing it was decided then to make a GIS. We collect then the energy generated at the power plants, and we then take it with one line towards Bier, going through the test facilities in Ansaldo. So all this we made for an internal review, listed all the different activities, how they got introduced or how they got executed. So when we start here in September, the very first challenge was to get engineering on, basically doing variant study, taking decisions, and preparing documents for the construction permits. There was a federal decree that was signed in September, but nevertheless, we needed to make sure that ST was going to give us the go ahead. So there was a lot of very close communication with the ST and all of the authorities, with the municipality. And we actually got, by the beginning of November, confirmed, yes, this is the way that we're going to do it. Start of construction was just a week after. We needed to be quick because we needed to assemble a GIS hall We wanted an indoor GIS. This GIS then was able to arrived the beginning of December. It was erected in weeks just before Christmas, because between Christmas and New Year, these 2 weeks here, we wanted to pull the cables, just to make sure that with the idea that many contractors were not going to be on site. Unfortunately, many contractors thought the same thing. So actually, it was a very, very busy time. I see Rudy is the same, because he of course, you suffered as well, or not suffered, but yeah, worked as well along us on this time. Then in January, we then were cabling control protection systems so that we can come into February for testing. And finally, we on the 24th of February, we were able to energize that GIS. Go a little bit back. So basically, on the 24th of February, that was our deadline, or the deadline that I was given to energize the GIS, which we called Uwe Ludwig, substation of Ludwig, because everybody was confused between power plant or power plant Bier and substation Bier, and then the grid connection for the power plant in Bier, which is not a substation. It was confusing. So Ludwig seemed to be a really different name, and within hours, people just got accepted the name, because that helped us to put back things together, at least in our minds, so that we could do actually the work as the way we needed to do. So on the 24th of February, we're able to energize the bus bars and then say to GE, okay, guys, you have here the grid, you can connect, we have a grid voltage, and then they could start of course, all this is parallel with much, much work, setting everything else in place, as you see from that green areas, to turn this to a power plant with step-up transformers on the GIS. But that was a day that we did, because we could then take time for our interface testing. Yeah. So so these are 6 months. I try to scale them down to make a comparison of a regular project or a standard execution time. So I needed to go this small, so to just in very standard, not in particular, regular grid connection project, which takes us from a pre-study. This would be the equivalent to when we receive that request for a grid connection. Then we can study the variants, the different ways, take all the stakeholders in place. Then we take a variant and we go down in the detail to make sure we have everything in place. Then so that we can ask for a construction permit. Then we can start with all the purchasing orders, finding the equipment. Then we can plan the construction site, then do the construction testing. All this got condensated in this very, very small time. So the amount of resources, the amount of energy required, it was extremely intense. And in December, I can tell you it was cold, it was dark, and it was bitter for many, many people that would rather be celebrating Christmas and New Year. It took a lot of courage and a lot of talking. We were discussing one point, and there was some sort of agitation. And so I tell this guy, so you know what? I think the only way we can get through this project is to be reminded, each one of us, that I am tired, and the person I'm talking to is as tired as I am. And this kind of like brought in a dynamic that was, I think it was really important to be able to get this through. But let me take you through some of this, what I'm saying, this schedule that I'm showing here, it actually happens. And I have photographs to show you. So again, our starting point by the middle of 19th of November, we already had the first slab, concrete slab. This is the GIS. But a week later, we already had the floor for where the GIS was going to be constructed. by the end of November, we are already putting the GIS hall on top of it. By the 7th of December, when the GIS arrived, we already had that GIS hall in place to receive the GIS. But that was not the only work that it was be doing. The cabling had to be already prepared. So by the time we are already preparing the structure, which is going to, we didn't have time to make it underline. So we did have to use a lot of bridges to get the cable on site. Mid-December, GIS is full in progress. This one here to the very far left is a cableway to that Ansaldo testing facilities. Here to your right is the cable connection to the step-up transformers. And I just like it because it just captures as well the darkness that is building up and the people keep on working because we had a really long hours. By 19, the idea was to have the GIS in place by Christmas, again for the layout for the cables. And by the 20th of December, we already had this bridge placed on the protection for tubes for the cable. By end of the year, we had already put the first 3 cables in. And here in this one here, by the end of December, you see all the cabling being ready for our connection of the control and protection systems. By this, which was the main work in January. There's a lot of work going on, but it's just the highlights of the main work being done there. By the end of January, we're getting ready for the high voltage test of the GIS. Beginning of February, then this here is the power supply units. With we didn't have much space either, so it's always all going into the same container. This container that you can see here, these batteries and the power supplies are towards the end of this container. Cables are already in place by the end of by the beginning of February. Then here in this photograph you see, but on the other side there's as well much work. The power plant, the transformers, the connections. Here we see this bridge that we had to build for the step-up to connect the step-up transformers, and they are going to be connected in parallel. So this is what we see here between them. Then by the 20th of February, we already had the high HV tests for the GIS. Which passed really well. As well, the high voltage test for the cables. We had at the beginning, we had 4 runs, and in the beginning, the first one, there were some partial discharges that were difficult, that could not be ordered. So there had to be some adjustments, but this is all while everybody else is working on this facility. So I think towards the end, they made a really good job. And then once it was settled, the right parameters for the testing equipment, it went actually really, really well. Which means that this is the 20th of February, looks like this. This is the Monday of the week that we commissioned. And this here is Friday. So just for me, an illustration of the amount of work that came from everybody to be able to go on Monday from a construction site to on Friday be able to deliver a substation. Just loads of work and loads of people involved. Few thoughts. Few thoughts. But in the beginning of the project, in the project's execution, there was internal talks. The standard processes could not be used. I mean, this is going to take us to either suspend or substitute by quicker processes. The project needs to be prioritized. We need to make resources available to be able to handle this. one of the points I mentioned a few times is this existing cable connection was a must to be able to keep that timeline that we had received from the federal government. Material supply was not easy last year, I think you all remember, and that was something that we had to take into consideration. How can we make it work? Then as well, construction permits. So we there was meetings with the ESTI authorities and other authority, the municipality, to exchange information and work quick and take decisions there. So of course we always had to see how we could avoid surprises, because as soon as we had one surprise, there would have been the schedule would be compromised. We actually did have a couple of unforeseeable obstacles, but the people were in a setup so well integrated by then that actually the schedule we were able to keep a schedule, as you saw. And then an important point is about documentation. It's so important, documentation, but here we needed to take decisions on site. So there was that communication that we said, and here we're going to have documentation by after commissioning, to be able to work this out. And there were many other points, but just a flow into some of the thoughts that we had at the beginning. We did have afterwards a lessons learned. And these are just thoughts that I would like to share after this time of running. I think it's imperative when we have this kind of project, management support and trust, because we don't have time to go around decisions that need to be taken in place. Communication is always important in any project. But when you have such a lack of a scarcity of resources, it is a must. So, and everybody has to communicate on the table and quick. And everybody has to support one another. It's not only about doing your own work, but it's also looking around saying, oh, this also needs to be done. I'm here, I have time, I can do it. And you just do it and help your colleague or the other person that is next to you. I think that the more communication that is used does increase the acceptance to identify other ways to work. But when we talk, we're engineers anyway, so we're technical people, and when we talk about making solutions, it is often efficient. And there was, of course, a major point. And that is that safety at work cannot be compromised. However, it should not hinder the work that is being done. And trying to walk this is a very, very fine line. That's not easy. Again, the thought is more communication. And we actually did have additional safety officers covering each other and covering the situations. And not only with the CIGRE, for our project, we had four local site managers, also to be able to cover the amount of the range of work, the windows of work. But we also have additional external safety officers helping. And I think that overall, GE as the owner of the power plant, or the constructor of the power plant, there was a complete group of, I think I heard 50 of safety officers working on the. So that was a main issue. And then maybe, time is getting also scarce again, but this is a question I do hear a lot. Should we have now, did this project establish in Switzerland a new standard to execute this kind of project? And my question is always, a couple of dots, because there were many circumstances that led us to this project. There are many considerations to be done before making a standard. That is kind of like a breaking of this concept. There were many parallel processes required. Normally, in a regular execution, they flow one next to the other. But if we reduce one process, another one is going to be hindered as well. variant studies. There is a reason why we study different variants to optimize the final product. But there's construction permits that in Switzerland can take a long time. There's a lot of purchasing regulations that we have to follow. Material delivery is not. We were able to find equipment to deliver, but if this is an integration, so that is. But I think still we showed that it was possible, that we made it, and maybe that could be an incentive to see how we could do it next time. So, well, thank you for your interest.
Thank you very much, Nora. I'm looking at the clock. I think it would be good if there's a question. We can do 1 or 2 questions to Nora. There were some in the chat. Marcel, you can help me.
Yes, exactly. So I think the questions were about this supply chain. Can you elaborate how to get the GIS and other equipment which in such a short period? We got this question from 2 people, from Stefan Gauder and also from Robert. So Nora, could you say something about supply chain?
Well, as I mentioned before, there were many things that were in place to be able to bring this together. And one thing it was that the purchasing of equipment, and we basically shopped around to see what was available and spoke with many partners and with many suppliers. And so the GIS, which was the main issue, was actually for some reason, I was not in the beginning, I can't tell, but this GIS was available, and they only had to arrange it for our needs. With the cable, we have frame contract with 2 suppliers, high voltage suppliers, which in this case, it did show that it did help a lot. We have the suppliers already in hand that we can go on to, and they just went ahead, started production straight away. And the contractor, and then what we did was with the contractors in place, GE, basically work with their contractors. So the civil contractor that worked in the GIS was the same one that was already in place doing work. So the supply chain was a lot of communication. Sometimes I did feel that I spent weeks, 50% on the phone, talking with people and bringing them together. So yeah, it is special. So I do think there's one thing I always say is that lessons learned are good and important, but lessons learned have a context. So to be able to reproduce it in other projects. So
you bring us to the next question, Nora. So first of all, I remember this parallel shopping thing, especially for private life. Credit cards will be heated quite quickly. But we have another question from Walter Hohlaus, and he says, like, are you planning to do other projects now with similar fast processes, or was this a one-time speedy project? Do you think you take away something from this very fast implementation then?
Well, as far as I know, this is a one only. I think that many lessons what we can learn here is that we can make it. Yeah, but that's what my last thought that I shared in this last slide is that before we make it a new standard, let's consider the full frame. One thing that there were many things that happened in this project. My most enriching point in this project is that I got to know so many people that I, even internally in SwissGrid, that before I didn't have the need to talk to. So, and see that we're not a one-man show or one-woman show. There's just a huge amount of people working into that. And when we have it, when we're able to just see the ship together, we can be very efficient.
Very cool you made that. Thank you, Nora, for the interesting presentation. And
My
I
pleasure.
hope you will not be forced anymore to be that quick with that many shopping lights in parallel.
Thank you.
Thank you. And now we switch to Rudolf Meyer. He will show us an update on CIGRE session 24. And of course, CIGRE session 24 has also some kind of history. So we will also look back into history of session 22. Rudi, the floor is yours to give us an insight.
Thank you. Just before starting with that, thanks again, Nora. Yes, I suffered also a bit in that project. And for those who are interested in the Anlagenbautagung in September, I will do a perspective on that project from installation point of view, because we were mainly involved in the installation for 4G and for Swissgrid. So to add another perspective on this really unique project. So yes, I make it short because we're already on time. Thank you for the next slide. It's a little promotion on CIGRE and specifically the CIGRE session. You see here to make you curious what happened in 2022. And as you know, every 2 years there's the next session. So the next session will be in 2024. We had an interesting program also with nice Swiss startups with Gelitix, Hyvodoct, and Linea in the drone space. We had an NGN presentation. We had women in engineering, so it was in energy, sorry. So it was an interesting year, 2022, and 2024 proves to be even better. You can switch forward, Marcel. Oh, yes, you can skip that. Oh, yes, there's also room for social events, as Nora mentioned. The important thing for successful projects is that you know each other, or you get to know each other, and this is also one part of the CIGRE session, to get to know people, not just in Switzerland, but from all over the world. There are, I know, this time, or 2022, there were 3,600 delegates participating, so there's a lot of people to get to know, all experts in their field. You can get one further. For 2024, yeah, I'll do this quick. We have quite a lot of papers, Swiss papers, that will be presented. We received the abstracts, and we are now in the process of reviewing these abstracts at the national committee level, and then there will be the full papers by beginning of the next year, and so everything will be ready for late summer 2024. You can see here the main topics that will be presented from a Swiss perspective. Can go on further. Yeah. So you can imagine 35 papers. Huh?
We will send out the slides so you can have a look at the titles calmly later on. Huh? Bye-bye.
And you can imagine 35 papers to review the abstracts and the paper. That's still quite a lot of work also from my colleagues in the National Committee. So thanks already here for the work to be already done and to be done. Next page, please. So yes, Paris is always worth a trip. It's as always at the end of August. Book early because the Olympic Games are just before CIGRE session, and there's the Paralympics in parallel. So be quick in booking and making your arrangements. And yes, of course, we were also very interested in having more individual members at CIGRE. So if you go to the homepage or on the ElectroSwiss page, you'll find the link to register immediately. So that allows us to do such interesting programs as today. Thank you very much. No more comments from my side. Marcel, some closing comments?
Yes, we have also some national events for those who are joining from national. First of all, there are online formats. So even if someone from another country would speak some German, you are welcome to join that. We have an expert talk format, which will be on 31st of August about energy, and on 21st of November about railways and energy systems there, and also the secondary technology within trains, the communication part. And then we have another forum, which is basically monthly on every third Wednesday, one exception in July, because we want to be before the summer holidays. This is about self-consuming communities in a local area network on 5th of July, and then about standards in electric mobility on 16th of August. And then, of course, many of you like the on-site formats in Switzerland, which is about substations. We mentioned that already. Rudy will talk about the BIR project again there. Then we have also power lines on 8th of November. We have renewables on 14th of November. And we have a new format on 22nd of November about electric fleets for companies or communities. And then we also can recommend you the big CIGRE meeting point on 22nd of March, which is about future grids and flexibility trading. So this is just a short outlook for our Swiss members, but anyone speaking German is of course welcome to join that online or on-site also. And with this, I can conclude to the open question and answer session, which Rudy and me will take together. So if there are now some questions, we check the chat. If there are some further questions to us first about the presented slides, and then in a second part, we have some main authors from the CIGRE session 24 here. They could also use the last part of the question and answer if there are any questions. So any questions, you can raise your hand or you can write it in the chat. We quickly give you some time. Maybe I will, in the meantime, go back to the CIGRE slide in the beginning to show you who was participating here, because you can see on the right side, we had 80% Swiss guests and then quite an impressive list of countries who were joining. Thanks to the Hitachi colleagues who did cover part of that, but we also were surprised. We have fans in Argentina. If you're still online, greetings. And hasta luego, puede ser. So there seem to be no questions.
No more questions.
Thanks. There is one. Are there any utilities left that still buy new SF6 switchgear? I think the presenters could go in. Robert, maybe you want to answer that. You're one of the suppliers.
Well, you see how the window shopping is done for the beer Kraftwerk. This one was a GIS with SF6 in such a short time. So yes, there is still, I think, yeah.
Yeah, it's still a main part of that, but some are progressing to SF6 free. Bruno, you want to make some statement also?
Yeah, that's correct. So there are many, they are looking for the future solution, but if it needed to have it very fast, proven technology, so there is still SF6 available. So we are following both products.
Michael Gatsch is still online, maybe? Yeah.
Yes, I think I can not add much more to this. I mean, we see the interest picking up very much, especially Europe, US, but still SF6 is a significant share, or the main share, even in these markets.
But can you give you an indication on the 420K? I mean, it's sub% that the new still, because they're just really freshly available. So the market share is still very low, no, at the moment. Is that correct?
I cannot say now percentage numbers, but what I can say, I mean, we are also some announced that we have pilot projects basically in Europe and US, for also since the breaker is capable of doing DTB and GIS applications. So we see really the interest for this to have these different applications covered with SF6.3.
I'm sure it will pick up, but it's really in a ramp-up phase at the moment.
Christian, maybe a statement from one who is doing shopping.
Yeah, I need to say that SF6 is not banned, and we ask for both alternatives, and then it's a question of price. we are certainly ready to pay a premium on SF6-free, but it has its limits.
Okay. So I think we'll still see some movements in the next coming months. I don't see further questions, but I still ask you stay 1 or 2 minutes online because I will share some more slides with you. And of course, we would like to say thanks also. Rudy, you maybe take the final word.
Yes, the final word is many thanks to, first of all, to the presenters, of course, who went into the burden of preparing the presentation, and of course for all the participants. It was really nice. We reached almost 100 participants, so I think that's a very good level, and I'm more than happy to do something very similar in the near future. So I wish everybody a nice evening, and we stay in touch. Thank you very much.
Thank you very much.
Bye.
Bye-bye.
Bye.
Thank you, everyone.
Bye.
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 Be safe.
Bye-bye.
Bye.
Bye-bye, everybody.